Electrolysis. Correct. So we should understand what is this thing. What is the meaning of electrolysis? Correct. So whenever we pass a electric current through an ionic compound, it breaks down. Correct? Yes or no? Fine. So what is meant by electrolysis mainly? So what is a basic concept? Before knowing what is electronics, what is a basic concept? Whenever, let's take a compound. So there are two types of compound. One is what? Ionic compound and other is covalent compound. So one is ionic and other is covalent compound. So ionic compound, whenever we pass electric current. Correct. So what happened this compound? This compound breaks down. So these are some of the basics we should know before knowing what is electrolysis. So what is meant by electrolysis normally? Correct. So what does it do mainly? So those things we will be learning in detail. Correct. But if you take about covalent compound, let me just take covalent compound. We cannot break down just by passing through electric current. Correct. Covalent compound doesn't conduct any electricity. Does not conduct electricity. So these are very, very important thing. So hence we cannot have electrolysis here. Electrolysis mainly is what? Passing of electric current to break down, that is to decompose or to break down the thing. Correct. But one important thing for the ionic compound is whenever this ionic compound is solid, then we cannot conduct electrolysis. Okay, so when can we conduct the electrolysis in ionic compound? For example, if it is solid in nature, I'll draw one small scenario here. In solid, we know the molecules are tightly packed. I'm trying to make it highly tightly packed thing. Okay. Big molecules I'm drawing to make it look tightly packed. Molten state. So here if I'm putting it, I can put it here as what? I can put this as plus. I can put this minus, plus, minus, plus, minus. It doesn't matter for me. Whereas in a molten, so this is for the solid part. Okay. Whereas if it is in solution, then what happens? There will be a mixture. There will be something like minus is here, something like plus will be there somewhere here. Correct. So it won't be that much closely packed. So which means in solution, at least it can move around. There will be some space. You got the idea? There will be some space where the molecules can move around. It won't be that much closely packed. Okay, it can move around. Okay, whereas in solids, it's very thick and there won't be any movement of the ions. Okay, so important thing to note here is solid. What would tell? The molecules or the ions are fixed. In solution, not fixed. They can move easily. They can move. The important thing here is, what is the keyword here? They can move. So electrolysis will happen only in solution or in molten state, not in solid. Correct. Then there are some important terms we have to know. Correct. For that, I will draw another box here. Just to fill it with this thing. Okay. It's fine almost, I think so. This is fine. Now let this be an electrolyte of solution. Electrolyte. Okay. And let this be a cathode, the left side. That is a negative one. So negative electrode is called what? Cathode. Let this be a positive one, anode. Positive one is anode and negative one is cathode. And these two things are supplied to a cell. There's a difference between cell and a battery. Cell in the sense there will be only one positive terminal and one negative terminal. Okay, power supply, battery, plus and minus. It doesn't matter. Okay, as of now, this is not that important for you guys. Fine. So normally we connect the positive side to anode. So for that purpose, I'll just make this as bigger, plus. And this as a negative side here. Positive, negative side. And the positive ion, this is called my cation. Cathode is negative, but positive ion is cation. Negative ion is anion. Correct. And then we got something called the electrolyte solution here. Correct. So I'll tell you what is this electrolyte. What is the purpose of this? This electrolyte, whatever I'm talking now here, this is the ionic compound in solution state or in molten state. This is the ionic compound in molten or in solution state. Correct. And what is my anode? Anode is a positive side. Correct. Yes. And what is this anion and cation? So anion, negatively charged ion. What is anion? Negatively charged ion. Negatively charged ion. So we have learned that like poles repel, unlike poles attract. So this will be, anion will be attracted to anode, and cation will be attracted to cathode. So that is the reason we given cation and anion. But always remember, cathode is negatively charged electrode. So what is an electrode? So if you ask me what is an electrode, what is cathode or what is anode? So it's a graphite rod mainly. So mainly what is a cathode or anode? It's a graphite rod which helps to conduct, or graphite, what is the main purpose of graphite? Correct? Electric current. Yeah, through graphite only what, so what is this electrode? Electrode is a rod which is made of what? Graphite, through which electric current can pass. To an electrolyte. So not that much big of a thing. Now let's see an actual example of the same. Electrolysis of a molten compound. That is lead to bromide. Correct. So what is my lead to bromide? For this, I'll draw a box here. It is my electrolyte mainly. Electrolyte, which is my lead to bromide. Then what will be at my anode? Positive electrode, and what will be at my cathode? So first thing, I'll write here as lead to bromide. Lead to bromide. Correct. So that is nothing but my lead, Pb, bromide, PbBr2. Correct. So if you want to understand this thing, we have to draw the same thing only, same diagram, cathode and anode here. But what is my electrolyte here? Here it is PbBr2. Correct. It is my PbBr2. So let's take about bromine. Correct. Let's take about bromine and let's take about Pb, the lead. Correct. So Pb has got 2 plus. 2 electrons it has to lose. Correct. That's the reason lead to bromide. Lead to bromide. And bromine, Br minus. So which is the negative ions here? Negative ions is bromine and negative ions is anions. That will get attracted to anode. Whereas Pb2 plus, positive ions will get attracted to cathode respectively. Correct? So at cathode, I have to mean what? Lead here, Pb or lead. At anode, I have to name here what? Bromine, negative ion, it's Br2. And at cathode, what happens here? Cathode take electrons. Cathode, what happens in anode? Anode oxidation happens. Oxidation happens. So what is oxidation? Loss of electrons or give electron. Cathode take electrons or reduction. it takes electron. So what happens in this? The lead ions take the electrons to give lead. Anode, giving away electrons. Giving away electrons. Correct? So how can I write this equation? So at the positive electron, what happens? Bromine. Correct? It takes these electrons to bromine. Correct? Minus 2e minus will give Br2. Or else I can tell what is happening in this. In the cathode, it is taking the electron. Anode, it is giving the electron. That's the reason we are subtracting here. This is a product at the positive electrode. That's it. So for examination trick, we can use something called panic. That is, positive is anode and negative is cathode. So for this, we can use the examination trick. So let's see some electrolysis. The reactions at the electrode. Okay, so for this again I'll draw a box. Electrolyte, and this is my anode, this is my cathode. Okay, so if I give NaCl solution, sodium chloride solution here, what will be the anode and what will be the cathode? Correct. So ions from NaCl, we know what is it? Na plus and Cl minus. Correct. And suppose if I am taking the electrolyte in water thing, H2O. Correct. H2O, we know very simple thing, it is H plus and OH minus. So at anode, what will happen? At cathode, what will happen? So if I take the cathode reaction here, so cathode, what will do? It will take this H plus ion, will take the electrons from the chlorine. But chlorine, if I'm taking chlorine here, correct, what is anode actually doing? It gives away the thing, right? Correct? Or else if the chlorine ions are formed here, Cl2 is here. So what I should do here? 2Cl minus will give me what? Cl2 plus 2E minus. The chlorine gas is released. Chlorine gas is released at anode. So it is giving the 2Cl minus and is giving the electrons here. Correct? It is giving the electrons, and this electrons is taken at what? Cathode, to produce hydrogen gas. So hydrogen gas is released here. molten solution, anode reaction, cathode. Here I will give it as, let's take same thing. I'll give here as concentrated HCl. Okay, so the ions from the HCl is what? HCl will give me H plus and Cl minus, and in water I'll get H plus and OH minus. So in anode, what will happen? Same thing, chlorine gas 2Cl minus gives what? Cl2 plus 2E minus. Chlorine is released. Chlorine gas is released. Cathode, what will happen? 2H plus 2E minus will give hydrogen. So here also hydrogen gas is released. So this is about the concentrated hydrochloric acid. But this is for a concentrated hydrochloric acid. What happens if it is dilute? If I replace this with dilute HCl, correct? Then at the anode, cathode will remain same. Cathode 2H plus 2A minus, that doesn't matter. But anode, what will happen? If it is a dilute thing, instead of this chlorine, at anode, what will be happening? Oxygen will be produced because OH minus will be used. 4 OH minus will give what? Oxygen plus water plus 4E minus. So these things you will learn in detail in redox reaction in class 11. Okay. So this is our solution and this is my half equation at the cathode. Lead to bromide. At the cathode we know Pb2 plus 2E minus will give Pb. Sodium chloride. Cathode 2H plus plus 2E minus will give hydrogen gas. Correct? Sulfuric acid H2SO4. Same thing, 2H plus plus 2E minus give H2. Correct? Hydrochloric acid. Same thing. Copper 2 sulfate. Copper 2 sulfate. Cu2 plus plus 2E minus will give 2Cu, or else you can just put Cu, that's enough. So these are some of the half equation cathode. What is it? Cathode? Cathode, it will gain electron plus 2E minus. Cathode, it is gaining electron. So cathode, or I can say reduction. or I can say gains electrons or takes electrons.